fun from them. Okay, so this paper is 76. And it's what's what of circles. We're just going to call it circle definitions because that's just easier. But it is a organizer of all the vocab words that come up with circles, followed by the definition, followed by a column where we're going to draw an example of it. It is a flip book, but you don't have to treat it as such. It's up to you. Today, what we're going to learn is a couple of words from here. Some of them you should already know, and then we have some new parts. So this is where you want highlighters, because highlighters really help draw your attention. When this is just a sea of words in black ink, we want highlighted words to draw our attention to, like buzzwords, keywords, critical words. Okay, so the first critical word, and don't ask me why it's not the first box, is the word circle.
I mean, if it was me, I'd put that as the first box, but, you know.
It's not the first box. We are dealing with circles this entire unit. I am going to zoom in so you can actually see what I'm fixing to write. 200. 200 works good. All right. So we're looking at these definition for circles. Notice it says the set of all points in a plane at a given distance from a given point in the plane. That's a little repetitive. What it means is there is a point somewhere on the paper, and then there is an infinite set of points surrounding that one, and they have the same thing in common. They are the same distance from that one point. That's what equidistant means. They don't use the word equidistant, but equidistant means equal distance. So we have this point, which is called the center of the circle. I'm going to call it A, point A. So if I wanted to talk about this circle without writing the word circle, I can write the notation circle A. And you always name circles by the center point every time. Okay. Now I want you to take your pencil and I want you to draw points all the way around. And then I want you to get gradually closer with your points so that it looks like we're trying to show that, hey, even though these are the only points I'm putting on here, how many are actually on this circle? There's infinite. It's the same concept as with a line. How many points are on a line? Infinite. But I only see 2. Well, those are the 2 you're looking at. A line has so many points that they're so close together, it looks like just a smooth stroke of the pencil, when really it's all those infinite points clustered together. The same concept holds true with a circle. We will draw circles. For example, we're going to draw a circle and we're going to put 1 point on it. That does not mean there's 1 point there. It just means, hey, I want you to look at that point. Okay? Now we're going to move to the word radius. Where is it? Underneath it. Don't ask me the logic behind this. Radius is a critical word, and I'm going to only highlight the R. If you highlighted the word radius, that's fine. It's okay. I'm only going to highlight the R, though, because I need you to know that for this unit, if we're talking about R equals something, we mean the length of the radius. Now, if we have a circle and there is more than one radius drawn, the correct plural word, looks very weird, is radii. You don't say radiuses like, that's not a word. You say radii. So if we have a circle with more than one radius drawn, then we would say that how many radii do you see? Okay, so what is a radius? If you need a ruler, let me know. I've got little rulers. A radius is a segment that connects from the center to the edge of the circle. From the center to the edge. This would be a radius. And what's really cool about circles is when you have one given circle and you have multiple radii, they all measure the same length. So if this is a radius here, and then I have another one over here, it would also be a radius. They're all around the circle and they measure the same length. So it connects from the center to the edge. Now what we're going to do is name one of them. We're going to name one of them. Let's call this circle A, and we're going to call this point right here B. So if I wanted to talk about that specific radius right there, I would call it segment AB. Or what's another way to call that?
BA.
Yes. Now scroll to the top. What word do you think I'm going to do? Diameter. And these words should not be new, right? You've learned about these words at some point. What is a diameter? A diameter is a segment that is within the circle, but it goes through a very specific piece of the circle. Do you know?
The center.
The center, every time. So what I want you to do on this picture is draw the center. You can label it A. And then I want you to draw a segment connecting edge to edge, circle to circle, and it's passing through the center. And we're going to call it, we'll call it BC. If I wanted to talk about this diameter, I would either call it BC or what? CB. Remember, when you're labeling segments, you only use two letters. Where do you start? Where do you stop? You don't name letters it might pass through in the middle. You would not call it BAC because it's a segment, not an angle. So you would only call it BC. It's a diameter because it passes through A, right? Okay, going back to the last vocab word, can you tell me how many radii are drawn in that picture? Two. There's two. Two radii. Can you name one of them?
AC.
Very good.
AB.
Very good. AC and AB, right? You with me? You off the phone? Everybody? Off the phone? Y'all good? So radius AC and radius AB, of course you could reverse those letters. Diameters do what to circles? Do you know? I'm looking for a phrase here. That's exactly the phrase I want you to learn. Okay, so this unit, listen to me carefully. This unit is a very challenging unit because it forces you to be a problem solver. I don't know if you remember from the first week of school, but I said that I'm going to teach you math, but I'm also going to try to teach you how to be a problem solver because I feel like that is something your generation is lacking, and it's because of technology. Push a button, get an answer. You know, Chat GPT, Google. I feel like problem-solving skills have disappeared because technology has taken care of the problem-solving for you. This unit forces you to be a problem solver. And what I mean by that is every question is different. Go back to the right triangles. The reason you liked the right triangle unit was because the sine, cosine, tangent pictures were the same. You just labeled the triangle and then knew which trig function to use, right? With these circle problems, the pictures are totally different every time. Preview of what's to come. Like, look at those examples. You got different stuff in there. I see a right angle. I see a diameter. I see radii. I see an angle, an arc. Like, it's always different. And so every problem is a new approach, which is why this is challenging. Now, as I've taught this over the years and noticed kids struggle with it, I've learned how to try to, like, give you the tools to be able to attack it. The first tool, first of all, you got to know your vocab words because it really helps. Second tool, diameters do what to circles? Will you say it again?
Cut them in half.
Cut them in half. That is something you need to, like, highlight in your mind. Diameters cut circles in half because it's going to come up every time a diameter is drawn. Okay, and it's gonna help you. So keep that in the back of your mind. Diameters cut circles in half. If you want, you could even, there's a little bit of room right here. You could say cuts. We'll just draw the circle in half. You could add that there. So if it cuts the circle in half, how many halves are there? Two. So every time a diameter is drawn, then you have two half circles, which is a vocab word, semicircle. Every time a diameter is drawn, we have a semicircle. The prefix, meaning the word in the front, semi, means half. When you hear of companies having semi-annual sales, it means the sale halfway through the year. So semicircle, half a circle. So we're going to come over here and we're going to take this circle, we're going to draw the center A, then we're going to draw a diameter. We'll keep it consistent, we'll call it BC. And then we're going to take our highlighter, and we're only going to highlight one of them because if we highlight both, then it just looks like the whole circle got highlighted. So we're only going to highlight one semicircle. So from B to C. Notice I traced around the edge of the circle. That is called an arc. And because it is connecting on that diameter, B all the way to C, it's half the circle, so it's called a semicircle. Now there is another one there, but I don't want to highlight it because I said it would highlight the whole circle. So there's two semicircles here. Now let's see if you know the math behind it. How many degrees are in every circle regardless of size?
360.
360. And the way to remember that is if I'm facing this direction and I do a 360, it means I've completely turned around. Like skateboarding, skiing, rollerblading. I'm trying to think of what, even bike, what is it, trick cycling, whatever. You know what I mean. BMX, thank you. I couldn't think of it. They do 360s, and that's where they do a complete spin around. So every circle has 360 degrees in it. Put that in your catalog in your head, like, okay, that's one of the things that I have to think of every time I start a circle problem. If a diameter is drawn, then you have two semicircles. How much do they measure? How many degrees do you think is in a semicircle?
180.
And how did you get that?
I divided it in half.
You know there's how many in the total? 360. And if a semicircle is half the circle, then it would measure half of that. So take your pencil, and I want you to come right here, and outside of this, I want you to put that arc measures 180 degrees. Semicircles measure 180 degrees, okay? Now, as we were talking about semicircle, and as we highlighted the circle along the edge, we used a vocab word that we're now going to cover, which is called arc of a circle. What is an arc of a circle? It is just a word to describe when you're looking at a portion of the edge of the circle. And you are talking about in terms of degrees here. So if you come over here, we have our circle A right here. I'm going to put a point B and then a point C on the circle, and I want you to take your highlighter, and I want you, well, you don't have to do your highlighter if you don't want to. You can do this two ways. This is what I tend to do when we solve problems. I tend to take my pencil and I do like a squiggly on the arc that I want to draw my attention to. That way I'm not having to highlight like too much. Because if you highlight too much, it kind of takes away from the whole point of the highlight. So if I have that little squiggly there, it means I want you to direct your attention to the edge of the circle, starting at B, going to C. Or you could reverse that and go from C to B. Now, if I want to talk about arc BC, then I would use the letters that it starts and stops at, and then I'm going to, wait for it, y'all, watch out. I'm going to draw an arc above it. So if I'm talking about arc BC, I will write the letters BC in capital, and I will draw a little arc above to say I'm talking about the edge of the circle, not some segment BC, okay? And you could reverse that. It can also be CB. Now, the neat thing about arcs is there's actually 3 types of arcs. You've already learned the first one. It's the semicircle. The second and third are called minor arc, major arc. I want you to take your highlighter and I want you to highlight this, ooh, that's too much, this block right here and across. And the reason we're doing that is because I want you to know that those 3 vocab words are all talking about the same thing. It's just there's 3 different types. It's either a minor arc, a major arc, or a semicircle. Semicircle is the only one that doesn't actually use the word arc in it. Now the cool thing about minor arc, major arc is, I've said it before, the way mathematicians name stuff is intuitive, meaning the word is telling you the definition. If it's a minor arc, it means it's less than 180 degrees. Less than 180 degrees, meaning less than half. So we are going to draw the exact same picture as our semicircle, but we're going to highlight a different section, okay? So we're going to draw circle A with diameter BC. And then we are going to put another point on here. Let's put it right here. We'll call it D. Then I'm going to take my pencil and I'm going to do the squiggly on the arc I want you to focus on. We're going to focus on B to D. arc BD is clearly less than half the circle, right? We have the diameter on there so we know exactly where half is. So arc BD is called a minor arc because it's less than half. And by the way, minor arcs are always labeled with 2 letters. Just 2. What do you think major arc means? More than 180, more than half. Okay, so a major arc means more than 180. You need to know that major arcs can be labeled as the word major, major arc, or with 3 letters. Now here's what I mean by that. Let's go to the picture and draw it. We're going to draw the same picture. And we're even going to put the same point D right here. But we are going to draw our squiggly line in a different spot. We are going to go from D through B all the way around to C. So you will notice that it's definitely more than half the circle. There's 2 ways to name that arc. It could be called major arc. Now you have to use the endpoints, DC, or major arcs can also be named with 3 letters, and the letter in the middle would be the one you passed through. So order matters here. You do start with the letter that you start the arc at, and then you include one that you pass through, and then you end at. Can A be in the name of any arc in this picture? Let me ask the question again. Can A, the letter A, be in the name of any arc in that picture?
Both.
Because it's not on the circle. It is the center. So I'm glad I asked that because I want you to understand, like, if the center of the circle is the center, it's not on the edge, it can't be part of the arcs, okay? So the other way to name this, I'm going to put or, you could call it DBC. And then, of course, it looks weird because it's 3 letters. And then you draw a giant arc above it. But that is another way to name a major arc. Okay. Oh. Alright, so we are holding off on that. Come over here. Hold off. We got congruent chord. Alright. Go to the word chord. What is a chord? A chord is a segment in a circle that stretches from the circle to the circle. So for instance, if I have segment AB going from the circle to the circle, then I have chord AB. The way I think of it is, have you an acoustic guitar? If you look at an acoustic guitar, you know where the hole is to allow the sound to come out. You know how the strings look across the hole? Y'all with me? I always visualize an acoustic guitar, and like that's the string that kind of passes over the hole. A chord, and I say that guitar because what do guitar players play? Chords. They play chords. They learn chords. That's how they make music. So a chord is a segment stretching from the circle to the circle. Now, if it passes through the center, then it is a chord, but it's a special chord called a Diameter, okay? So a diameter is a chord, but it has its special name because it's actually going through the center, all right? We didn't quite finish, did we? When do we get out? 11? Okay, good. Then we're good. Okay, so if you will, come over here. There's one more vocab word right here, and then we're going to go to the other sheet. The vocab word I want you to look at says central angle. Central angle. A central angle is an angle whose vertex is the center of the circle and the sides are considered radii of the circle. I want you to draw a center point, we'll call it A, and then I want you to put two radii, we'll call them B and C. Because we have the points, the center point A, and then we have the two radii coming out of it, notice we actually have an angle here. We're very familiar with angles. Everybody's familiar with angles. You can name them by one letter, the vertex, in this case the center. You could call that angle A. But if I threw another radii in there like that, then you cannot call that angle A, because now there's too many. You would have to name it by three letters, and you do trace the angle. You can either call it BAC or CAB. I want you to take your pencil and put an arc right there. When we say central angle, we are talking about the actual angle measure right there in degrees, okay? Now, notice the angle opens up to form this arc here. Do you see that? Think of it like a flashlight shining. So angle A is opening up to form arc BC, which is important. Which now let's move to this sheet. This one right here. Page 78.
We have 7 minutes.
We're good. Page 78. A central angle is an angle with its vertex at the center of the circle, and its two sides are radii. Now, how many degrees are in every circle? 360. So, don't draw this, because I'm going to erase it in just a second, but watch. So, from A all the way around back to A measures what?
360.
360. So, from here all the way around back to here also measures how much? 360. I need you to know that the sum of all central angles in a circle is 360 degrees. That is something that goes in the back of your mind. You're going to use it. Now, for example, we have this picture here. What is the central angle here? We have angle, you could call it B, but we're going to name it with three letters. We have angle A, B, C. And then you will notice angle ABC measures how many degrees? 84. Here's the math behind central angles. If the angle is 84, think of a flashlight, then the arc it's opening up to also measures 84. That's the math behind it. They're equal. The degree of the arc formed by the endpoints of the central angle is equal to the degree of the angle. Now, if you have a single angle drawn in the circle and you can show the arc, then you can actually write some more info here. Look at this right here. Notice this says little m, arc AC. This means measure. What is the measure of arc AC? From A to C measures what? 84 degrees. Because arc AC is 84, you don't have to highlight this if you don't want to. You can just let me do mine. Notice the back side. A through D to C. Does that complete the circle? The green arc that I've drawn and my purple squiggly, does that complete the whole circle?
Yes.
Yeah, if you put them together, you've drawn the whole circle, right? Almost looks like Pac-Man. Well, if the purple arc is 84, do I know enough in my head to find the green arc? What is it? How do I get it? Yes, remember, the whole distance around is 360. I know this chunk's 84, so the measure of arc ADC will be 360 minus 84, which is what?
276.
276. That is the math behind this practice sheet, okay? You've got to remember it is a puzzle. It's a domino puzzle because as soon as you start getting a little bit of info, the rest falls into place, okay? Here are the things you need to look for. 3 things. Number one, whole circle equals 360. Number 2, diameters cut it in half. Well, what number does that equal? What number is associated with cutting 360 in half? 180. And then the third thing you need to keep in the back of your mind is central angles equal their arcs, which we just did here. So those are the 3 things you're going to use to solve this sheet. So look at number 1. I find it easier to go to the picture and label what I can instead of trying to look at this and find it, okay? So go to what you know. I know from here to here is 21, right? How many, question, is there a diameter in this picture?
Yes.
Yes. How many diameters? 2. Okay, this might be another thing worth writing at the top. If you have 2 diameters, you have, do you remember the vocab?
Semicircles.
You do have semicircles. Think back to something from units prior. If 2 straight lines have crossed, we've got vertical angles. That's another tool to completing. So let's make a note. 2 diameters equals vertical angles. That is huge. That's going to help tremendously. So if this is 21, what's the backside?
21.
Very good. And then we just learned that central angles equal their arcs. So if this is 21, then what's this? 21. What about down here? 21. Diameters cut the circle in half. Now here's where you have to get good at muting out info. This is why my board is helpful, because I can highlight and erase the highlighter. I want you to focus on 1 diameter. What does this measure?
180.
180. What chunk does this measure?
21.
Do I have enough to find the other chunk?
Yes.
180 minus
21.
21, which would be 159. So this is 159. Y'all, I know you're packing up, but please watch this. So if this is 159, from K to L, come inside the circle. What would this angle be?
159.
159. You see how this falls together?
Yeah.
And then you got vertical angles. So what's this?
159.
159. And then what's this? 159. I love it. And then now, all you have to do to answer the question is to read the circle and put the numbers together. You just found every every single piece. Where is it?